Hello, I'm Mike Coe, and together with my partner Lizzie, I live in the autonomous house here in Worcestershire. As a self-build project, the aim from the very beginning was to reduce the demands made on the environment to an absolute minimum, and to me this meant building for autonomy. Although the house isn't certified, it was designed using the Passive House Planning Package, and the modelling shows an unprecedentedly low heat demand of around 4 kilowatt hours per square metre per year, around a third the minimum required to achieve Passive House certification. During construction, we paid meticulous attention to airtightness details, installed very high-performance triple-glazed windows, huge amounts of insulation, and critically, the house is extremely high mass. This is one of the two main floors in the building. Made from poured in situ solid concrete, it weighs at least 50 tonnes. We used high mass materials wherever we could. The concrete staircase, the solid brick internal walls. We even reclaimed blocks from old electric storage radiators and built some of the internal walls from those. This high thermal mass is crucial because it stores up heat during the summer months and then begins to put it back into the house as we move into winter. This, combined with super insulation, high levels of airtightness and large areas of true south-facing glazing, mean that we can dispense with any kind of active heating system at all. So that means no boiler, no wood stove, no heat pumps. But it works. So reducing the need for fuel for heating to almost zero is the first step towards autonomy. But there are other energy demands made by the average household which are impossible to control. That is, if you're connected to mains water and drainage. Providing clean drinking water, very little of which is actually consumed, and taking away and treating waste use considerable amounts of energy, and there's not very much you can do to control that, unless you take a radically different approach. The autonomous house has a big secret, but you can't tell what it is from ground level. That's because it's down here, below the ground, in a full-size basement plant room. Here in the basement, these huge tanks are used to store harvested rainwater. Every drop of rain which falls on the roof of the house, conservatory and garage is routed down here to these recycled bulk orange juice containers. The water passes through a slow sand filter to purify it, and then up to header tanks in the roof, from where it provides the entire water supply for the house. In all, 17 tonnes of water can be stored down here, and there's no mains water connection for backup. We, the occupants, are responsible for managing our own water supply, and if we run out, it's nobody's fault but ours. All the pumps for the rainwater harvesting system are driven by 12-volt batteries, charged during the daytime by solar electricity, so the system doesn't normally use any imported energy. Those same batteries also supply the low-voltage lighting inside the house, which is much more efficient than running it from the mains. But how can you manage on just harvested rainwater? Well, one part of the strategy is to have enough collection area plus enough storage to see you through dry spells. But equally important is to reduce water consumption to an absolute minimum, and that's where this comes in. This is the chamber for the dry composting toilet system. It's really just a giant bin into which all the human waste falls down two insulated chutes from the straight-through pedestals in the house above. It's a dry system, so it doesn't flush. In a house with conventional toilets, around 40% of the water supplied is used for flushing. We use none. The composting toilet system produces a liquid compost, a little bit like Tomerite, which can be drained from this tap down here. And it also produces a solid compost, which is taken out of this trapdoor, and just smells very faintly of damp earth, nothing worse, and can be put straight on the garden. So no need to visit the garden centre to buy compost. To stop smells drifting up into the house, the compost chamber is ventilated by extracting air from this duct. This means a constant airflow down each toilet, so they act like extractor fans and smell less than the conventional variety. As in most airtight houses, there's a mechanical ventilation system, and by using this to extract the air from the toilet chamber, no additional power is used, but the heat generated by the aerobic composting process is reclaimed and contributes to keeping the house warm in winter. The only other waste produced by the house is grey water, and this is disposed of straight into a soakaway in the garden, so there's no need for a mains drainage connection. Another example of autonomy. Finally, hot water is produced by these oversized solar panels on the roof. With half a ton of storage in this heavily insulated tank in the basement, hot water is still available even after several days of overcast weather. Combined with an intelligent power diverter system from the photovoltaic array, it's hardly ever necessary to top up the hot water using external power. When the sun isn't shining, this house is not totally autonomous. It then imports power from the electricity grid, which is the only external service connection. Overall, the attention to detail and efficiency has paid huge dividends. With only a small electricity bill and grants for the renewable energy systems, living here produces an income of £500 to £600 a year. And the autonomous features don't only save money, they reduce the load on our already overstressed environment, which benefits not just ourselves, but everybody else as well. And the house is a delight to live in. Plus there's something reassuring about being in charge of your own essential services. It puts you back in touch with the world around you. Which leads to just one question: why aren't all new houses being built like this one?